Yes, this is the one more, not any one more. This is the one more. Now focus on the individual element inside. The carbon you burn in excess oxygen, CO2. H4 or H itself burn in excess oxygen, H2O. That's what you meant. Now we're going to use this information back to the question. So we have a combustion of carbon. What do you think it becomes? Not a lot, CO2. I'm so sorry. Then the hydrogen combusts, give you H2O. How about this compound? Look at individually, carbon become CO2. Hydrogen become H2O. This is not a balanced equation. The main idea is to let you know what they become. Now I'm going to make full use of this information and solve it. Now, in order for you to master this energy cycle, I need you to be a little bit flexible in terms of how you write equation. You see, we are so comfortable to looking at equation from left to right. Now, I want you to reverse it. Sometimes you need to write the equation from right to left. Sometimes I need to write the equation from top to bottom. Sometimes bottom to up. So I need you to be a little bit more dynamic, learning how to read the equation in multiple directions. Let me show you what I mean here. Let's begin with the first one. Can you see that this is carbon? So I want to combust my carbon. If you want to combust your carbon, focus your attention on this particular carbon atom. You want to combust it, you add oxygen to it. Because it's only carbon that can burn in oxygen. Now, how many oxygen do I need to burn finish the 2 carbon? 2 moles of oxygen. And what is the reason? Because using 2 moles of oxygen burned in the presence of carbon, I can give 2 CO2. So I want you to focus your attention only on this part of the equation. Ignore the rest. Only focus on this part. 2 carbon react with 2 oxygen, 2 CO2. You can see equation balance, right? That's what I mean by dynamic. You must be able to read vertically downwards. Not only that, how many carbon is burned? Only the reactant. 1 carbon burn is minus 393. 2 carbon burn minus 393 times 2. That's what they meant. So we finished the combustion of a carbon. Let's move to the next one. Hydrogen. You see there's a hydrogen here? I want to burn finish all the hydrogen. And what is my ultimate goal? To give me H2O. That is the end goal. Focus your attention on here. Focus right here. So your H2 need at least 1 oxygen to give you H2O. So that means you got 3 H2 here. I think only 1 of the H2 can take 1 oxygen to form H2O. So I still short on a few oxygen. So hence, I will plus 1 more oxygen molecule. The reason is because if you want to completely combust your H2, you must form 3 H2O. 3 H2 plus 2 and 1, 3 oxygen atom, 3 H2O. So I'm forming 3 H2O molecule. Look at this equation independently. Since you want to combust 3 H2, I'll be using 3 times of minus 286 because I'm combusting 3 hydrogen. Can you see combusting 3 hydrogen? 3 H2O. After looking at independently your carbon combustion, your hydrogen combustion, now I want you to look at everything on the left. Can all the thing on the left hand side give you your carbon dioxide gas and water? Yes, because carbon burn in oxygen, give me CO2. Hydrogen burn in oxygen, give me H2O. So all the things combust, give me CO2 and H2O. That complete our first equation, forming CO2 and H2O. Now let's take a look on here. Carbon, not carbon, no, combustion of ethanol. So you combust your ethanol, what do you need? You need oxygen. Remember just now you added in 2 O2 and 1 more O2? Now just like math, you cannot just plus oxygen for nothing. The equation must be balanced. So if you plus 3 oxygen on the left, you will plus 3 oxygen on the right. It must be fair. Right now, I want you to focus your attention only on the right-hand side. Ignore the rest. If you combust your ethanol, what do you form? CO2 and H2O. Just nice. CO2 and H2O. Would they combust to give me CO2 and H2O? Let's check whether the equation is balanced or not. 2 carbon, 6 hydrogen, and how many oxygen? 7. Just nice. 7 oxygen atom. This whole equation is balanced out. Now this is combusting 1 mole. Only 1 mole is minus 1368. And here we go. This is what we call an energy cycle because it completes as a loop. Can you see that? So how do we find the answer, or how do we solve the delta H1? Use the technique, which is called the clockwise energy. Can you see this is a clockwise energy? Equals to anti-clockwise energy. So it doesn't matter who is absorbed heat, who releases it, it doesn't matter.